guys, we're looking at question 2a, which says that we should simplify x squared plus 7x over x squared minus 49. In order to simplify this, we're going to start with the numerator. So we're going to factor out the highest common factor of x squared and 7x, and that's going to be x. So if we factor x out, we're going to get x plus 7. If we look at the denominator, which says x squared minus 49, we can observe that that's the difference of two squares. It's the difference of two squares because the first term, which is x squared, is a perfect square, and the last term, 49, is a perfect square as well. And the sign between them is a minus sign. To factorize the difference of two squares, we put the roots of the square terms in brackets. So we're going to have x plus 7 in one of the brackets, and we're going to have x minus 7 in the other. Then if we look carefully, we are able to cancel out x plus 7 at the top with x plus 7 at the bottom. So our final answer will be x over x minus 7. Question 2b says we should find the value of r when x to the second power times x to the 6th is equal to x to the r. So what we're going to do first is that we're going to simplify the left hand side. The bases are the same, so when in laws of indices, once the bases are the same, we're going to add the powers. So we're going to keep the base x, and we're going to have 2 plus 6, and all of that will equal to x to the r. We're going to have x to the 8 will equal to x to the r. So because the r and the 8 are in the same position, it means that r has a value of 8. Question BII says find the value of s when s to the third power is equal to 8. So in order to find the value of s, what we know that if it is raised to the third power, if we find the cube root of the s to the third power, then we are going to find the value of s. So anything that we do to one side, we'll have to do to the other side. So finding the cube root of s cubed gives us s, and the cube root of 8 gives us 2. Question 2c says the diagrams below show a triangle and a quadrilateral. All angles are in degrees and are written in terms of a and or b. I says for the triangle, show that 2a plus 5b is equal to 171. So for this question, we're going to pull on all the knowledge we have as it relates to the angles of a triangle. So we know that all the angles in a triangle add up to 180 degrees. So 3b, a plus 2b, and a plus 9 will equal to 180 degrees. So let us look at all the like terms. So we're highlighting the a's and also the b's. So we have 3b there and we have 2b up there. So what we're going to do now, we're going to formulate an equation with these terms, and we're going to equate it to 180 degrees. So we're going to have a plus 2b plus 3b plus 9 is equal to 180. Let us simplify. We're going to have 2a plus 5b plus 9 is equal to 180. So we're going to subtract 9 from both sides. If we subtract 9 from both sides, we're going to have 2a plus 5b is equal to 180 minus 9. So we're going to have 2a plus 5b is equal to 171. Therefore, this has been proven. Question 2c II says for the quadrilateral, show that 7a plus 8b is equal to 342. So we're going to identify all our like terms and we're going to equate all of that to 360. So let us identify all our a's. We're going to get those written down. So we're going to have 6a plus 3a minus 2a plus 3b plus 3b plus 2b plus 18 is equal to 360. So we're going to simplify the a. So 6a plus 3a, 9a minus 2a gives us 7a. 3b plus 3b plus 2b gives us 8b plus 18 is equal to 360. So next we're going to subtract 18 from both sides. So we're going to have 7a plus 8b equal to 360 minus 18. So we're going to have 7a plus 8b is equal to 342. Hence this is proven. Question 2, part C, I says solve the pair of simultaneous equations in part I and II to find the values of A and B. And it also says that we should show all working. So the first thing that we're going to do, we're going to write down the equations from these two parts of the question. So the first one is 2A plus 5B equal to 171. And the second one is going to be 7a plus 8b is equal to 342. So the first thing that we're going to do, we're going to name them. So the first equation, we're going to call that equation 1, and the second one is called equation 2. We're going to be utilizing the elimination method. So we're going to multiply the first equation by 7 and the second one by 2. We do this to make the magnitudes of the a's the same because we're going to be eliminating a. So we're going to multiply 7 times 2a, which will give us 14a, and 7 times 5b will give us 35b, which will be equal to 7 times 171, which will give us 1197. And this will be now our equation 3. Let's use 2 to multiply the next equation. So 2 times 7a gives us 14a, and 2 times 8b gives us 16b, and 2 times 342 gives us 684, and that is our equation 4. Because the magnitude of the a's are both the same and they are both positive, we're going to subtract equation 4 from equation 3. So 14a minus 14a gives us 0, 35b minus 16b gives us 19b, 1197 minus 684 gives us 513. So we have eliminated the a, so we're going to find the value of b. So it's going to be 19b divided by 19 is equal to 513 divided by 19. So 19 into 19 goes 1. So we're going to have b is equal to 19 into 513, which gives us 27. We're going to sub b equal 27 into equation 3. I chose equation 3, but you can use any other equation to find the value of a. So let's write down equation 3. 14a plus 35b is equal to 1197. Then we're going to fit in 27 for b. So we're going to have 14a plus 35 open bracket 27 is equal to 1197. And then we're going to continue. So it's going to be 14a plus 945 is equal to 1197. Next step, we're going to have 14a is equal to 1197 minus 945. So let us simplify. We're going to have 14a is equal to 252 So we're going to divide both sides by 14. So 14 into 14a goes 8 times, and 14 into 252 goes 18 times. So our solution to this is a is equal to 18 and b is equal to 27.